Hey everyone, welcome to this whole new series, DevOps Simply Explained, where we'll be exclusively talking about DevOps. So, what is DevOps? Is there any standard definition for this? What tools comes under DevOps? Like this, we have many questions. So we thought we'd make a video for this in the simplest way possible. This is Rajesh and you're watching. If we ask many industry experts to define DevOps, each of their definitions will vary. So, what is the standard definition of DevOps? Well, the answer is there is no standard definition of DevOps. However, many of them define it as a set of tools, some define it as some kind of software. Well, those don't come close. First, let's start with what is not DevOps. It is not a team, it is not a role, it is not a set of tools, it is not a set of question and answers for our next interview. It is not about zero failure deployments. So what is DevOps then? It's a mindset. It's a culture. So DevOps is a culture which combines many practices, methodologies whose primary focus is to break the walls between the teams with ways to fail fast, learn from the failures, and focus on the shared responsibility. So let's break it down. The above definition in the simple term refers to development of a quality software or a product in a short span of time. Let's go back in time before the DevOps era. The developer writes the code, they build it, and hand it over to the QA team, and they verify a few test cases and approve it for the final release for the customer usage. This whole cycle will be half yearly or yearly once. After releasing the software, if the customer has any issue with the application, it is raised as a complaint to the operations team, and as this is not related to the environment itself, the defect ID is opened for this and passed to the developer. So, the operation guy's responsibility lies in forwarding the issue to the developer. And developers sometimes used to say that whatever code they did was working fine on their local or dev machines, and they asked QA or support team to find why the application is not working properly on the production service. So here, developer's responsibility ends post-build phase. This kind of ping-pong will incur time and effort with nobody focusing on the actual issue. We can clearly see here developers and operations works in silos and scope their responsibility within certain environments. The industry realized that even with huge development and operations team, issues take time to solve and new features take time to reach end users. The biggest problem, however, is developer focuses on the new features and operation focuses on the stability of the application. And that's the big wall between them which needs to be broken. So DevOps helps in bringing together developer and operations team so that a shared responsibility model helps in delivering features faster by also maintaining the stability. So some may even define this as DevOps, a combination of developer and operations, and there is nothing wrong about it as it is proved. So like we discussed earlier, there are many definitions for DevOps outside, and all the definitions which include high quality product in a shorter span of time will stand true. Okay, so far good. As most of us are familiar with the saying, easier said than done, so this exactly applies to our current cycle. It is easier to say that we want a high quality product in a shorter span of time, but how do we achieve this goal? That's the bigger question that needs to be answered. As we discussed earlier in the definition of the DevOps, that it is a culture that combines many practices or methodologies, namely continuous integration, continuous delivery, continuous deployment, etc. These are some of the practices which are going to help us to achieve our goal. And each of these practices are in turn supported by a number of tools. Each practice mentioned above is very important and we are going to discuss each of them one by one. Since DevOps has many definitions, we would like to break it into three main categories. Number 1, DevOps as a people. Number 2, DevOps as a process. And 3, DevOps as tools. So if we speak about DevOps as people, In a traditional approach, the two teams who are at the opposite end of the line are developers and operations team. Usually, operations team are not familiar with developer terms and vice versa. So, it finally ends up as a blame game between them, which has high chances of the issue heading into a different direction and losing focus on the important stuff. DevOps as people helps us in overcoming this issue. So basically, DevOps members are the ones who have some knowledge about coding, entire build process, and at the same time aware of the activities done by the traditional operations team. So if an issue arises, they will be helpful in identifying the root cause of it and forward all the details required about it to the respective team so that it can be fixed properly. To put it in simple words, DevOps brings the developers team and operations team together. DevOps as a process. What is continuous integration? In traditional approach, there will be a team of developers who would be working on their assigned tasks. Each developer work on a part of the code, and in the end, all the code is combined into one and we start building the code. If the build fails, then it becomes a tedious task to identify which part of the code written by which developer is causing the issue, and it delays the work of other developers too because they cannot move forward unless the issue is fixed. This may have a potential delay on the product release. Clients will not be happy as the expected deadline could not be met. So, we'll take the same scenario but from a DevOps perspective. The same set of developers working on a specific task assigned to them. Instead of merging it all in the end at once, what we do differently here is we'll have a centralized code repository to store the application code. Once the developer has completed his task, he will commit his code to the centralized repository. We'll make a configuration in such a way that for every commit pushed to the repository, an automatic build is triggered to validate the code. This build will be happening in Jenkins. Don't worry, we'll discuss about Jenkins in detail in our future videos. We'll get the result of those builds within minutes such that the errors in the code can be identified immediately. By this way, we can also be sure that which developer's code exactly caused the issue. So, to simply put, continuous integration is a practice or process which helps us to identify the errors in the code as quickly as possible by triggering as many builds as required. Continuous delivery. The traditional approach, once the application is built, the application will be deployed in the lower environments manually. After this, it will be validated with functional and non-functional test cases, and then it will be approved for deployment to production environments. In continuous delivery, this manual process must be automated for making application versions ready for deployments. Continuous deployment. Well, this almost is similar to what continuous delivery is, except for one major change at the last step. In large organizations, as far as lower environments are concerned, we can risk the deployment of the code immediately after the CI step is completed, because even if something goes wrong, it has no direct impact on the customer. But whereas in production servers, that is not the case. We cannot risk anything causing the customer impact. So, the last part of the flow, deployment of the application, is done only on a specific release window so that the customers are informed. But for the startups who are building the release pipelines from scratch, they should aim for continuous deployments. Natural maturity in DevOps is to move from continuous delivery to continuous deployment practice. DevOps as tools. To support DevOps mindset and to have DevOps processes in place, we need tools. Let's look at a typical set of tools used that is not exhaustive but should give us an idea. Source code management. As the name itself indicates, these tools helps us in managing the codebase of our application in a centralized repository that can be accessed and modified by the developers at the same time. GitHub, Bitbucket are some of the popular tools that are being used currently. Continuous integration. Earlier, we have mentioned that we can trigger a build for each commit made by the developer, integrate the work of other developers to detect immediate errors if any. Jenkins is most popular CI tool which helps us to achieve this. Containerization. All the required packages that are required to run the application can be grouped in a single Docker file, which in turn helps us to build images out of them. We can simply compare the Docker images to the .exe file format of the windows we get when we download a particular application. Once we run these images, it helps us to run the containers which runs the application along with its dependencies. We will see more of the Docker in our future sessions. Usually, a huge application will be broken down into small Docker containers, and to manage a large number of containers, you can use container orchestrators like Kubernetes. If you are interested, click on the link on the top right corner. Selenium is one of the famous testing tools that is used in the CI process. Jenkins can also be used as a release tool. Configuration management. Configuration management tools helps us in configuring the servers based on the minimum requirements for the application to work properly, like a specific Apache version, DB version, application property files, etc. Some of the famous tools that helps us in achieving this are Ansible, Chef, Puppet. Jira, ServiceNow are some of the ticketing tools which helps us on the operations side. Monitoring. Once the application is deployed to different environments, the main difficult task comes next. We should be aware of the spikes in the application reliability and performance so that we can act proactively before customer complaints. We can monitor different metrics like CPU utilization, memory consumption, storage, etc. Some popular monitoring tools in market are Prometheus, New Relic, Datadog, etc. Friends, that's it for this video. We hope that this video was informative for most of you. Further, we'll be dropping more videos related to DevOps and DevOps tools. So please don't forget to subscribe to our channel so that you don't miss any of those. Learning.